All right, so we're going to do our third installment here on exponential functions. This time we're going to really kind of sink our teeth into this fully and write our own exponential functions for a given situation. So just a quick look on top here of what we've already done. We've already looked at the general form of exponential functions, y equals a to the bx, where a little bit bigger, a is our initial value. Right, that's the y when the x is 0. B is the multiplier. Right, and x is the input. That's how many times we're going to be multiplying. So that was how we kind of started this, and then we looked a little bit in the second installment at percentage of growth and decay. And really the equations for growth and decay are what we see here in our second and third one. So if I have a situation, right, this right here is just our b, right, a times b to the x. And if we're dealing with percentages, right, we're going to move that decimal to the left 2 times, and we're going to deal with them as a decimal rather than with the percent sign in there. You can see here, if I'm adding to 1, then the b is going to be bigger than 1. And if that multiplier is bigger than 1, that's going to be a situation where we're dealing with exponential growth, right? Things are increasing because the b is greater than 1, and our graph is going to look like this. As I go from left to right, the curve is going to go up. And if I think of this one over here, right, where a times 1 minus r, if I have my rate and I subtract it from 1, right? So say my our number of coronavirus patients is going down by 10%, right? I would subtract that from 100% or from 1, and I would get 90% or 0.9. So my b would be less than 1, right? If I'm multiplying by something less than 1, that means it's going down. It's decaying. Easy for me to say. Decay. I'm having a tough time with that today. All right, that means our graph would be decreasing. And as I go from left to right, it's going to go something like that. How steep it is and all that is going to depend on the numbers, but it's going to go down anyway from left to right. Okay, so those are kind of the formal formulas. We're not necessarily going to have to, plug in. You're going to have to maybe even use intuition would be okay with these. Okay, so we're going to do 2, 3 quick examples here that are going to line up with our homework so you can kind of see what needs to be done. So example 1, Sarah invests $850 into an account earning 8% interest per year. Okay, so it's going to walk us through here what to do. What is the multiplier? Right, so if I look at the equations that I came up with here, interest is always going to be a case where, if I give the bank or my stock account, we're hoping that we get, well, let's just stick with the bank. Stocks can go up or down, right? If I give it to the bank and they promise me 8% interest per year, which would be really high. I wish they gave you that much interest per year. 8% interest per year, it's going to go up, right? If I put in $100 this year, then at the end of that year, I would have $108, right? And then the next year, I would have 8% of that amount of money. So that's going to grow slowly at first and then quickly as the time goes on. So what is the multiplier? So you can see here I'm adding. Interest is always going to be growth. So I'm starting with 100% of my money. And interest, I'm adding 8%. So I'm going to end up with a total every year of 108% of my money. And remember, we don't want to put the percentage sign in our equation. So we're going to take the decimal, all right, and we're going to move it to the left twice. So my multiplier, the b, is going to be 1.08. Write an equation to find the value y after x years. So I know my equation generally is going to be y equals a times b to the x. the B I determined already in the last step was 1.08. And up here in my initial problem, it tells me how much she's starting with. So my equation is going to be y equals 850 times 1.08 to the x power. And then it asked me here in step 3, how much money will there be in the account after 12 years? So when it's telling me the amount of time, the number of times I'm going to multiply it by 1.08, that's the multiplier, once a year for 12 years. So my x equals 12. So my equation would be y equals 850 times 1.08 to the x power, which is 12. So depending on the type of calculator you have, or if you're using, if we're doing these types of problems on Delta Math, they have a good calculator built in. You can do right on the screen where you can type it in just like it looks right there, and it'll give you the correct answer on the right side of the screen of the equation bar. If you're using like a phone calculator, you gotta be really careful how you type these things in and make sure you're doing it correctly, because it doesn't always honor the order of operations if you don't put parentheses and things in the right spot. So what I would do is I would probably do this first if I'm working on a phone, right? And then multiply it by 850. But I worked it out ahead of time, so if I do that correctly and plug it in, I should get $2,140, and I think you have to round up to get 45 cents. So that's not too bad, right? Like 850 bucks, and after 12 years, it's gone up pretty substantially. So example 2, the city of Clovis currently has about 120,000 residents. It's been growing at a rate of 3% per year. If Clovis continues to grow at this rate, how many people will reside in Clovis in 50 years? So what is the multiplier? Well, we're starting with 100% of the current population, and every year we're adding 3%, right? So that means my multiplier is 103%. Or I really want to write that as a decimal, right? 1.03. I got to take my decimal and move it to the left twice to go from a percentage. So 1.03, that's my multiplier, that's the B. It's going to ask me to write an equation, so I need to know the initial value, right? I know how many there are right now, that's the A. So write an equation for X years, so whatever we want. So y equals, let's just do this, A times B to the X. I know that A is 120,000. And B, the multiplier we just determined was 1.03 to the x. So now I can plug in whatever number I want for x, and that's going to tell me the population in that many years, right? If I plug in a 0, 1.03 to the 0, anything to the 0 is 1, I would just have 120,000, right? So in year 0, this year, it's 120,000. So I can plug in whatever I want. Part C asks me, well, let's plug in 50. Let's see what happens in 50 years. So when you high school kids are about to retire from long careers working, how big is Clovis going to be? Let's see. So y equals, take our equation, 120,000 times 1.03 to the x power, and here x is 50. And again, depending on which calculator you're using, I mean, you really need to use a calculator to solve these unless you want to sit there all day doing multiplication. So get a good handle on how to plug these into your calculator. But so again, I worked this out ahead of time, plugged it all in, and it should come out to 526,068.72. Right, we're not likely to have 0.72 of a person, so I'm going to go ahead and get rid of that, and I'm going to round that up. to a 9. So 526,069. So that's pretty big. That's 520,000 people's really big. So think about that. That's in 50 years, if Clovis keeps growing the way that it's growing right now, it's going to be more than 4 times the size it is right now. So Clovis with 5 high schools, maybe soon to be 6 high schools. If it keeps growing in 50 years, it's going to need 4 times as many schools. It's going to need 25 high schools in Clovis. That's crazy. That's like Los Angeles. Okay, so example 3, last one here, and then we're done. Luis buys a new car for $27,000. It depreciates 12% per year. What is the value of the car after 6 years? So first thing we want to do is make sure we know what this means, right? So he's going to buy a car for $27,000, right? That's our initial amount. That's how much the car is worth. Depreciates, right? When you buy a car, typically, unless it's some sort of classic, collectible or something that you're going to hang on to, a 63 Corvette you're going to hold on to for 50 years. Typically, you go and you buy a Toyota Camry, it's going to go down over time, right? Because you're going to drive it, it's going to get mileage, it's going to be worth less as time goes on. So when you buy a car, it depreciates or goes down, right? It decreases. So it's going down 12% per year. So our multiplier, right, the B, I'm going to start off, I buy the car and it's worth 100% of what I paid for it, and then every year it's losing 12%. So my multiplier is 88%, right? But again, I don't want a percentage, I want a decimal, so I'm going to move the decimal to the left twice. So my multiplier is 0.88. This is my B. So I know my A and I know my B. What is the value after 6 years? Right, so that's my X. So this is really the same thing as the last 2 problems, but it doesn't walk me through it step by step. I have to know what to look for. I got to find the A, I got to find the B, and then I got to find the X. Now I plug them all in, right? So Y equals A times B to the X. A is the initial, so $27,000. B is the multiplier, so it was 0.88. Right, less than 1, so it's going down, and X was 6 years. Again, I have to use a calculator to do this unless I want to sit there all day. So I did it ahead of time, and I determined that Luis's car was worth, should have a dollar sign in there, $12,538.91. So you can see a car is not a very good investment, right? If you put all the money you have into a car, in 6 years, your car is only worth $12,000. So it's been depreciated more than half in 6 years. So, all right, well, there's a few examples how to write equations from situations. Hopefully those get you off and running on Delta Math. Just remember, when you're dealing with percentages, you're going to always add or subtract the percentage from 100 and then move the decimal.